Hello everyone. So today I am going to start some question answer from elasticity chapter, and these questions are from SL Arora. So here we have the first question, that is a wire increases by 10 to the power minus 3 of its length when a stress of 1 into 10 to the power 8 Newton per meter square is applied to it. What is the Young's modulus of the material of the wire? So as you can see here in these questions, we have to calculate the value of the Young's modulus of the material. So we know from the formula that Young modulus Y is equal to stress upon strain. And stress is equal to force upon area, that means force acting per unit area, and strain is equal to delta L upon L, that means ratio of change in length to original length. Now, according to this question, it is said a wire increases by 10 to the power minus 3 of its length. That means here the change in length delta L is equal to 10 to the power minus 3 of L. So we know that strain is equal to delta L by L, and that has to be 10 to the power minus 3. And also another given data is stress, and that is equal to 1 into 10 to the power 8 Newton per meter square. So stress is equal to 1 into 10 to the power 8 Newton per meter square. And if you substitute all the values of stress and strain here, then you'll be getting 1 into 10 to the power 8 Newton per meter square divided by 10 to the power minus 3. Then it would be 1 into 10 to the power 8 into 10 to the power 3 Newton per meter square, which is equal to 10 to the power 11 Newton per meter square. So the answer would be the Young modulus of the material of the wire is 10 to the power 11 Newton per meter square. So this is our answer. So from here you get to know about the Young's modulus, and Young modulus is equal to stress upon strain. So here you have to put the values of stress and strain, and in these questions all the data are given already, so you have to understand it and then just substitute all the values here and you'll be getting the answer. Question number 2 is, what force is required to stretch a steel wire 1 centimeter square in cross section to double its length? Given y is equal to 2 into 10 to the power 11 Newton per meter square. That means in this question, Young modulus is already given, and we know that Young modulus is equal to force per unit area divided by change in length upon L. That means stress divided by strain. Now here we have to calculate the force. So first, this is F by A into L by dl. So from here F is equal to YA delta L divided by L. Okay. Now let's see the given data. First A is given. So A is equal to 1 centimeter square. Now as you know that whenever you are solving any numericals, and here y is given in the unit of Newton per meter square, that means in SI. So obviously we have to convert the centimeter square into meter square. And we know that 1 centimeter is equal to 10 to the power minus 2 meter. So 1 centimeter square is equal to 10 to the power minus 4 meter square. Okay. Now according to this question, suppose the initial length L1 is L and the final length is 2L, because in this question they have asked that what force is required to stretch a wire in a cross section to double its length. That means L2 is equal to 2L. Now from here we can say that means the change in length delta L is equal to L2 minus L1, which is equal to 2L minus L. That means it is L, right? Now we have already Y, A and delta L and L, so we can substitute all the values in the equation. So let's put Y, which is 2 into 10 to the power 11. Then A is 10 to the power minus 4. Delta L is equal to L divided by L. So L will be cancelled out with each other, and we'll be getting 2 into 10 to the power 7 Newton. Okay, so this is the answer. So what force is required to stretch a steel wire of 1 centimeter square in cross section to double its length? And the force required is 2 into 10 to the power 7 Newton. So here in this question, they have asked to calculate the force. So first you have to write down the Young modulus expression. Then from there you have to write about force, the expression of the force. Then you have to calculate the value of the force, and for that you need to put the value of A, then delta L, and Young modulus is already given. Now question number 3. Find the stress to be applied to a steel wire to stretch it by 0.025% of its original length. Y for steel is 9 into 10 to the power 10 Newton per meter square. Okay, so we know that Y means, Young modulus means stress upon strain. So from this equation we can write that stress is equal to Y into strain. Now in this question Y is already given. Y for steel is 9 into 10 to the power 10 Newton per meter square. And now we have to calculate the value of strain. Now here it is mentioned to stretch it by 0.025% of its original length. That means change in length, which is delta L, is equal to 0.025% of its original length. And here I am assuming that the original length is L. That means delta L upon L is equal to 0.025%, which is 0.025 divided by 100. And we know that delta L upon L means strain. That means now we have Y and we have strain, and then we can just substitute the values of Y and strain in this equation. So Y is 9 into 10 to the power 10 and strain is 0.025 divided by 100. And after calculating this value, we'll be getting 2.25 into 10 to the power 7 Newton per meter square. So this is our answer. Question number 4. A steel wire of length 4 meter and diameter 5 millimeter is stretched by 5 kg weight. Find the increase in its length if the Young's modulus of steel wire is 2.4 into 10 to the power 12 dyne per centimeter square. Okay, so according to the question, you have to remember one thing, that here in this question the unit of Young modulus of steel is in dyne per centimeter square. So we are going to consider this unit here, and we know that Young modulus Y means stress upon strain, which is force upon area divided by delta L upon L. And from this equation or expressions we can write that means Y is equal to F upon A into L by delta L. And from here we can write, that means delta L is equal to F dot L divided by Y into A. Okay. Now let's see the given data here. As you can see, the length of this wire is 4 meter. So we have to convert this meter into centimeters. So it will be 400 centimeter. Then we have given the diameter. So D is equal to 5 millimeter. Now again we have to convert this in centimeter, and we know that this would be 5 divided by 10, so 0.5 centimeter. But to calculate the area or cross-sectional area of the wire, we need the radius. So R is equal to D upon 2, which is 0.5 divided by 2, which is equal to 0.025 centimeter. And we know that area is pi r square. So this is 3.14 into 0.025. square, centimeter square. Okay, and lastly we are given the Young modulus, which is y is equal to 2.4 into 10 to the power 12 dyne per centimeter square, and another data, that is force is equal to 5 kg weight. Now here also you have to convert this kg weight into dyne. So first 1 kg weight in Newton is 9.8 Newton. So 5 into 9.8 Newton, and if you convert this Newton into dyne, so this would be 5 into 9.8 into 10 to the power 5 dyne. So just substitute all the values here. So first 5 into 9.8 into 10 to the power 5, length is 400 centimeter divided by 2.4 into 10 to the power 12 into area is 3.14 into 0.025 square. And after calculating this, we will be getting this 0.0041 centimeter. So this is our answers. You have to keep in your mind that here the Young's modulus is in dyne per centimeter square unit, that means in CGS unit. So we have to consider all the data in CGS unit. Question number 5. Two wires made of the same material are subjected to forces in the ratio of 1:4. Their lengths are in the ratio 8:1 and diameter in the ratio 2:1. Find the ratio of their extension. Okay, so first the given data are the ratio of the forces. So let's say F1 is to F2 is 1:4. Then we have the length, so let's say L1 is to L2 is equal to 8:1, and diameter D1 is to D2 is 2:1. Now we know that Young's modulus gives us stress upon strain, which is F by A divided by delta L by L. So from here we can write that Y is equal to F upon A into L by delta L. That means delta L is equal to FL by AY. Now we are going to use this formula. So from here we can write, so delta L1 is equal to F1 L1 divided by A1 Y, and delta L2 is equal to F2 L2 divided by A2 Y. Now here we are using Y for both of these because in the question it said the two wires made of the same material. That means the Young modulus of these wires are same. Now we are gonna take the ratio of delta L1 to delta L2, which would be F1 L1 divided by A1 Y into A2 Y divided by F2 L2. Now y will cancel out with each other and we'll be having F1 by F2 dot into L1 by L2 into A2 by A1. Now we know that cross-sectional area means pi r square. So let's say this is pi r2 square divided by pi r1 square. So pi will cancel out with each other. Now according to this question, F1 is to F2 is given, L1 is to L2 is given, D1 is to D2 is given, not R1 is to R2 or R2 is to R1. But we know that diameter means basically twice of radius gives us diameter. That means here 2R1 is to 2R2 is equal to 2:1. That means R1 is to R2 is equal to 2:1 as well. So we are going to use that formula. So from here, if you take R2 is to R1, which is 1:2. So just substitute all the values in this equation. So F1 by F2 means 1/4. Then L1 by L2 is 8/1 into R2 square by R1 square, which means 1 square divided by 2 square. So it would be 1/4 into 8/1 into 1/4. So 4 to the 8, 2 to the 4, which is 1 upon 2. That means the ratio of final answer, the ratio of delta L1 to delta L2 is 1 is to